All right, well, I will go ahead and kick things off. First of all, I just want to thank you all for coming in and participating today. A couple housekeeping things. I have a presentation to go through. I'll be doing that for approximately 30 minutes, trying to keep things not too long here. And then I'll be able to address any questions you have. If you have any questions, there is a Q&A icon, should be on Zoom, where you can go ahead and enter a question anytime you want. They'll queue up and we'll try and go through any questions that people have afterwards and summarize similar questions, etc. So today's presentation and webinar is really focused around Fluree at an introductory level. We're not going to be getting in and doing coding today, although this is a bit of a prelude to our next webinar where we will be doing some actual coding. And in fact, our next webinar will be, in the course of 30 minutes, we will build an entire application stack from blockchain all the way through to a real-time front-end UI. We'll have some information about that follow-up webinar and encourage you to register if that's something that interests you. Our focus today is really talking about some of the concepts, ideas, some of the benefits behind Fluree. We'll get into a little bit of how it actually works under the covers and hopefully set the stage for you to understand why Fluree would be a really good fit for your next application that you happen to be building. All right, and let me... There we go. So at a high level, what is Fluree? And sometimes I have to answer this in two different ways depending on the world that people are most used to or where they're coming from. Because Fluree really does sit at the intersection of blockchain-backed technology and data management technology, databases. So for people coming from more of a blockchain world, we tend to answer in one way, and people coming more from a database world, we tend to answer in a different way. And we'll cover both of these, but we don't necessarily see these as two different things. We see these as the same things, and we expect everyone will see these two areas as the same thing in the coming years. And part of how we would describe Fluree, not necessarily today, but a few years from today, would be that Fluree is a Web3 data platform. And in order to explain at least what I mean by Web3, I'll quickly recap what I mean by Web 1 and Web 2. So Web 1 was certainly the informational web. It was the kind of the explosion of hypertext, even though hypertext was actually developed in the 80s. Web 1 really gave us information to knowledge that other people had. And it was a person getting knowledge from another person. It was a very person-to-person sort of medium. Web 2 is really what we think of as the platform web. Web 2 is what when we decided we could actually build applications or have complete infrastructure sitting on top of this foundation. And certainly software as a service emerged out of Web 2. Salesforce was officially incorporated in, I think, 1999, although not a lot of people had heard of them then. So really around the 2005 timeframe is where Web 2 really took hold. And of course, today we still see the Web 2 concepts emerging with infrastructure as a service, data as a service sort of concepts with AWS or Google Cloud. But Web 2 and Web 1 still shared a very similar approach and similar architecture. It's a client-server architecture. There's a server, it's accessed over the cloud. There's clients that power or show you and perform the application functions. And at the other end of those clients, whether it's a laptop or a mobile phone or a desktop computer, it's a human. For the most part, it's a human. It's still a human interacting with other data and other services. And that's really where the concepts of Web 3 start to diverge, because Web 3 is really the first web that is based more around machine-to-machine interaction than it is based on human interaction. It is a data-driven approach. It's a data-first architecture, for what goes on in Web3, and it's all about interconnecting services and information. And to give you a sense as to how we're not quite at Web3 yet, or what we think about as Web3, I am sure many of you use tens, if not hundreds. I think a recent survey said even a mid-sized organization uses over 500 software as a service products within their organization today. And how many of those truly interact and share information and data? My guess is for most companies, it's 0 of them. So the Web3 is all about allowing data to interconnect. And if we think of something like a good sort of poster child for Web 1 might be Wikipedia, it's humans getting information. And if we think about Salesforce.com or Workday or even AWS as a Web 2 sort of application, what are the applications that exist in Web 3? A few examples that we're already seeing, and I think many of them will yet to emerge, are digital assistants. And I think we think about digital assistants more as an AI function, and certainly it's built on an AI foundation, but we're accomplishing AI today in Web 2. There's nothing sort of Web 3 about making AI happen. AI does need access to a lot of interconnected data, but we do have our brute force methods that we use today, like jam everything into a data warehouse or a data lake to make these happen. But the real key around a digital assistant is that it's interacting with the global ecosystem of services on your behalf. And in order for it to do that, it means we have to have this intelligent machine-to-machine communication. Certainly cryptocurrencies are an excellent Web3 example. You know, we've spent a lot of time talking about these ideas of software eating the world. That was popularized by Mark Andreessen, and we see it a lot and use it a lot. And Web3 is more about data and protocols. And in fact, I think the new mantra should be that protocols are eating the world. But if you think of a cryptocurrency, at its core, it is a protocol-based technology. It is based around machines interacting with other machines. The users sort of come via different apps or front-end user interfaces that are built around that ecosystem of that machine-to-machine communication. There's many other emerging technologies that are coming. But I think a really important thing is to think about the technologies we're using in each of these phases. You know, Web 1, for those of you that participated in it, not only was it just HTML, but if you did something a little custom, you were probably using CGI scripts and Perl. And you'd never build anything probably using those technologies today. Even if you're building an informational website, you would use the technologies that we're using around the Web 2 infrastructure, meaning it's backwards compatible. The technologies we're using in Web 2 can easily do the Web 1 sort of things in addition to Web 2. And Web 3 is really much the same way. So the Web 3 technologies are a superset of the capabilities that we have today. But it does warrant a new technology stack, and it warrants a slightly different approach. But if you want to build a Web 2-like application today, there's nothing stopping you from using a Web 3 technology stack to do that. In fact, it will not only take care of that, it will allow you that sort of forward participation into these concepts of the semantic web. So semantic web may be something that several of you are used to, and Web 3 might be something that you've heard even a long time ago. Web 3 was coined by Tim Berners-Lee, and in fact, I dug up this slide. It came from a speech he did in 2006. He started talking about the semantic web even earlier. Now keep in mind, Tim Berners-Lee was talking about hypertext markup in 1980. Yet we really didn't have the technology and the pieces in place to make it excel and do everything that we do until kind of the mid-90s is when everything was in place. And really, semantic web is the same way. And if you look at this stack that Tim Berners-Lee put up in 2006, so 13 years ago now, you'll see, especially if you're familiar with Fluree, you'll see a bunch of terms in here that are probably familiar to you. And Fluree is based on a lot of these standards and concepts. But this was also a stack that didn't necessarily have a technology in each of the boxes. In fact, there's a big box to the right called crypto. There's really never been anything in a semantic web stack that fit that. But we knew that if we were going to provide those things at the top level of this diagram, the trust and the proof, that cryptography and some sort of decentralized system would have to participate and end up being part of that particular stack. Let me get my little icon there. So this trust was very important, but it was really based on crypto being there, which it really wasn't. And then we also have other things in here like proof and unifying logic. These were basically placeholders at this time. And I think if you look at the time frame that this happened, 2006, we had a very important white paper come out in our community in very late 2008. And that was from Satoshi Nakamoto, and that was the Bitcoin white paper. And it started to lay out the foundation of a first global scale system that actually handled decentralization, cryptography, proof, and trust, a lot of these boxes that were missing from this diagram in 2006. And part of this is why we get into this, we don't think about blockchain technology and data management technology or databases as two different markets, because our view of the world is much like this one. All of this fits and coincides with one another to accomplish some pretty amazing things. So with Fluree, of course, everything's RDF based. We support Sparkle. We also support GraphQL, which didn't exist in this time. And so there's some of these technologies have evolved for things like unifying logic and rules. In Fluree, we support our smart function capability. And of course, other blockchains. In 2015, we had Ethereum, which really introduced the first usable smart contracts. Now, when we think about cryptocurrency technology or blockchain technology versus Fluree, I would say that when we look at things like a Hyperledger Fabric, or we look at things like an Ethereum, those are systems that are really based on financial use cases. You can sort of shove other things in there. It's not that you can't do other things, but they're really based around programmable money. So the smart contracts we have, the programmable logic and rules that something like an Ethereum or Hyperledger have, are really around this use case. And that is how Fluree is very different from other blockchain technologies, is we have a very data-centric and distributed and decentralized application viewpoint, not the sort of traditional financial management viewpoint of the cryptocurrency world. So how is Fluree, there we go. How does Fluree differ from different data management technologies, a database, if you will? And I'll highlight three key areas that we really bring to data management that a traditional database either doesn't have or struggles to have. And I'm not saying that you won't find maybe a case of a certain type of database or a specialized database doing some of these things I'm going to talk about. But certainly there is nothing out there that brings all this together in a single unified package as Fluree does. And I'll keep this along really three core themes: trust, leverage, and data scale. And some of the key capabilities that we have in each of those. So talking about trusting your data, Fluree introduces and contains these three features I want to highlight: immutability and tamper-proof data, embeddable data permissions, and decentralization. And it's important that I point out that item number one, you get automatically. It is always there and always present in any data you're managing within Fluree. Number two and number three require some setup and configuration, and you can use them if you want. But that number one is really important. And what I'm indicating here is that even without things like decentralization we think about in the blockchain space, you could still get all of the tamper-proof and immutable capability regardless. It is always there. And so what Fluree has in here is a blockchain style hashing of information. As Fluree basically updates information in the data stored, it creates a RDF formatted append-only log of the information. And that information is hashed in a chaining fashion like blockchains do. That hashing really does two things. One, it gives traceability of every data change. So anytime information is changed or altered, you have the ability to know exactly what the history of that piece of information used to be. It's always there. And the second thing is it provides a mechanism to detect if the data has ever been tampered with. And I think we have a little bit of blissful ignorance in some cases when we think about all the data we're currently storing in every one of our applications. And when you come down through it, you literally can trust zero data that is being stored anywhere. I mean, we try and put up firewalls, we try and do the things we can to protect the information, but we couldn't tell you with our current data that it's been tampered with. We have no way of detecting that. We couldn't tell you how the data originally got in there. Maybe we still have some logs of when it happened, but certainly databases are update in place, meaning they overwrite or they destroy the information that they're updating or overwriting. We have no true integrity around any piece of information that we have today. And we have the technology to address this. And certainly Fluree does at its core. This is just part of what it does automatically. The second item here, embedded data permissions. This is key and one of the terms we use a lot when we think about semantic web and leveraging data, a data-driven application approach, is that we need data to be able to defend itself. We have long got outside of the world that traditional data management technologies have always lived in, which is I have data being stored and I have exactly one consumer of my data, which is the application sitting in front of me. It controls the permissions, it controls everything about it that I do. And now, of course, anytime we're building an app, we have many, many consumers, our customers, our partners, or maybe we even have multiple applications inside of our organization. And within every single one of those application sources, we're having to recode data permissions because that's controlled at the source. And we think in this world, it's going to be critical for data to be able to defend itself, to be able to embed the permissions around the security of information along with the data it's protecting. And then, of course, as we're building APIs, we're building multiple apps, or we're sharing this information externally with partners, suppliers, customers, that data integrity is always enforced. We have not only have we saved a lot of work in recoding security, but we have no chance of accidentally missing something and not having things properly secured. So this is a really important concept, and I'll touch briefly on smart functions, kind of what it looks like and what some of the pieces are. And then, of course, this third item, decentralization. And again, completely optional. You get a lot of the benefits that we've talked about with trust and integrity here without decentralization. But Fluree allows you to actually distribute transaction validation responsibilities across multiple parties. And in practice, what that means is that multiple organizations or entities can actually jointly run a single database without any single one of them controlling it or having it exclusively behind their own infrastructure. And of course, we know this really is impossible today with any database. Somebody's always running it. Somebody's always controlling it. If multiple parties need access, the best we can usually do is have maybe some audit rights over that organization to make sure they're not tampering with things. But again, getting back to number one, we have no ability to prove whether data has even been tampered with or the origins of it regardless. And of course, this sort of technology addresses these concepts at its core. Now I'll talk about data leverage. So remember, I was going to talk about data trust, data leverage, and data scale. So how do we better leverage this data? We are in a data-driven economy. It's much different than it's a much different world than when we developed original relational database technology, what we were trying to do with it. And graph databases are the future. There's no doubt about it. It is the fastest growing segment in databases. And anyone who's spent a lot of time building apps knows either we use libraries or utilities to help us do it, but knows how much acrobatics we go through to get data out of something like a relational system and massage it, usually into like a data tree-like format, that we can consume it easily in the type of applications we're building today, or within data we're trying to feed to AI training or an AI engine. It's a lot of work we do, and graph databases just natively represent data in this format. So it is just the optimal choice for the types of apps we're building today and how we end up needing the information. It's just native. And of course, with semantic technology, it really allows us to start linking disparate data sources, joining them together, and treating them as though they were the same database. So this type of technology allows us to start to bring together information without having to dump it all into a data warehouse. And we just saw yesterday, I can't remember what company, just saw another Elasticsearch breach. And Elasticsearch, of course, is a very popular choice for getting data from a bunch of data silos and jamming it in as one central place so we can do queries against it. Part of the issue is, of course, we lose the security of each of the original data sources because we pull all the data out the back end, and it just introduces additional risk for data security. We love semantic graph technology, technologies like Sparkle, because what it allows us to do is actually issue queries across multiple data sources simultaneously as though they're the same database. So not only do we not have to go through all the effort of creating the data warehouse to begin with, which is expensive and time consuming, but we actually improve security because we can leave the security with the original data at its source. Again, data needs to be able to defend itself. So there's a lot of really interesting concepts with semantic technology, and it's really going to usher in the next wave of applications we're developing. Something a lot of people haven't seen before they get exposed to Fluree is time travel. And of course, with Fluree, we are keeping this append-only secure log of all data changes for the data traceability like we talked at and be able to prove immutability. One of the key things that we introduced in Fluree is we let our data indexes, which of course make our queries very fast, we index them along effectively 2 dimensions. Not only the traditional sort of indexing, but also along time. And this allows you to query Fluree as of any moment in history instantaneously. In fact, most of these queries come back sub-millisecond, even historical queries. So this has a lot of real practical benefits that come up. One key thing is that we can actually freeze time from a data standpoint across computation. And if any of you have done any high volume software as a service apps, you've ultimately dealt with race conditions, sometimes existing from the same server, which is, I have 3 functions that are serving some request, one requests data, and then the next one needs to get data, but the data has been updated since the first one requested it. And all of a sudden there's a conflict and you have an error in your application. And it's immensely difficult to reproduce. A lot of high volume applications spend most of their debugging time trying to trace down race conditions. And it's basically because you're trying to build a solid application on top of a data store that's constantly changing from underneath you. Being able to freeze time effectively allows you to treat your database, a moment in time of your database, as a variable you can pass around your code. It completely eliminates data-related race conditions. And now as we're doing more and more distributed computing, either through microservices, which have even more delays between multiple services acting perhaps on the same request, to even larger distributed computing, these race conditions are getting further exacerbated. Fluree allows you to lock in time and have complete guaranteed coordination, where a query at a certain moment of time will never ever change from underneath you, and allows computation to be coordinated. Perfect for today's architecture. Time travel also allows you to troubleshoot issues. So, you ran an integration process at midnight last night, and I don't know how many of you have dealt with these issues. Certainly I've dealt with more than I care to admit. And the integration fails. And someone comes in the morning and tries to rerun it, and the integration succeeds. Obviously, there was a problem with the data that made it fail in the middle of the night, but with a traditional database, you have no ability to get back to, no easy ability, certainly, to get back to the moment in time. With Fluree, again, it's instantaneous. You can grab that version of the database that was running in the integration, figure out what the issue is, fix it so it never happens again. And even things like customer support, time travel really plays into. You imagine a customer calling up and saying, hey, I was on your website and something that I was looking at said X at 10 o'clock this morning. And of course, your customer service rep says, I don't know, it says, why now? They have zero ability to go back and understand what it used to say. And with Fluree and this time travel capability, you can actually allow any application you build on Fluree to have time travel and allow your end users, this is for zero additional development work, allow your end users to say, well, I want to see this screen, whether it's a dashboard or an analytics screen or a product screen that a customer support person is looking at. Say, I want to see this as a 10:03 a.m. You will instantly time travel your entire application. So it's a really great capability and solves a lot of key problems. In real time is what more and more end users are developing for the applications we're building today. And of course, if any of you have built any scalable, more complex real-time application, you understand how difficult this can be to get right, to have the right security, to have performant. Fluree natively has this capability in it. Again, it's append-only log. It's used to just streaming out deltas of changes, which can be quickly picked up by any external service. So while in the case of Fluree, we're picking up those changes and we're turning it into this time-traveling semantic graph database that you can query, anyone can listen to these stream of changes. Trigger applications, trigger emails, populate the data into other data sources. All these changes of information are coming through in RDF format, which is immensely versatile. And we'll talk a tiny bit more about RDF. So that's data leverage. We talked about data trust, and now quickly talk about scaling data. So what does a data stack of Fluree look like? Well, at its core, this is what it looks like. You have the ability to basically add in more components, and I'll briefly talk about this, but when you download Fluree from our website and just run it on your laptop, this is effectively what's running. You're running a RDF-based immutable blockchain ledger that is acting as a graph database. You're able to interact with that via any of these three industry standard integration protocols. We have GraphQL, Sparkle, and then what we call FlureeQL, which really takes the power and analytic capability with Sparkle and sort of blends in the graph crawling capability of GraphQL. So you can use all three, one of these three, it's up to you and what you have the library's expertise or desire to use. And that's how you end up talking to your external applications. Your external apps here. So how do we scale this? So what Fluree allows you to do is introduce a whole nother layer to the stack that your apps can talk through. And we call it Fluree edge servers or query servers historically. And this is effectively like a content delivery network, but for your data. You can literally put these edge servers anywhere across the world you want. You can keep them right next to your ledger servers and scale them up and down quite quickly. They have immense versatility. So you have the ability to literally scale up these data sources to billions of queries per second. And these edge servers not only cache index information, and we write out these immutable indexes that make it very cacheable globally. Once they pull in that data for a segment of the indexes to serve queries, they effectively become in-memory databases. They are super fast. And unlike a content delivery network, you never have to tell it when to expire its cache or when to refresh. Because we're constantly broadcasting out the deltas and the changes, we're able to see these in real time. And we're able to pick these up and keep the edge network always up to date. And then lastly, through decentralization, you can take this blockchain ledger platform, this data platform that you're running, and actually start to distribute the transactional consensus around it. We have Raft, PBFT protocols, so if you want to extend this across a supply chain or into a consortium, you have the capability to do that. Okay, I'll quickly talk about how transactions happen. So we've talked about this idea of the semantic web, and really what it amounts to is you've now started to expose your data to more participants. which also means more participants can start to interact directly with you, more machines, this machine-to-machine sort of world. So if anyone can write transactions to you, how do we make sure they're valid? And this is effectively the checklist that a transaction coming into your database, or your shared data ledger, needs to go through. The first thing is every transaction requires a signature. We validate that that signature has not been tampered with, and who it comes from is an authorized user within the system. We validate the changes against the schema of the system, make sure that it adheres to your data schema. And then we start introducing smart function capability. And through smart functions, you're able to have very granular, really custom logic to not only describe the exact shape and characteristics your data must have to be acceptable, but also permissions. And we'll talk a little bit about smart function permissions right here. So how do we use smart functions? I've talked about data defending itself. How do we let data defend itself? And the short answer is we allow logic and rules to be embedded with the data that it's protecting. Going back to that Tim Berners-Lee diagram I showed at the very beginning, there were specific boxes in there to control that integrity. And I wanted to just give a simple example, because embedding these rules can be very easy, because you can actually leverage the data and the relationships that sit in the data to protect them. And this simple example I have here is a rule that says, that is, for example, across a multi-company supply chain network, and you want this rule to say only an employee from a company can create an invoice from that company. Meaning you can't have people creating invoices for other companies on the network, only your own company. So that's a simple rule. So if we have a transaction where someone is creating a new invoice, and here I have that transaction data in JSON, the invoice has a price of $2 and quantity, etc., and some relationships to the company that the invoice is coming from, NewCo, and the company that the invoice is going to, OtherCo. That's a simple transaction. This transaction is cryptographically signed, and this signature allows us to prove not only has the transaction not been altered while it was in transmission, but to also prove who it originated from. And if we end up having a schema or a database that ends up kind of looking like this. So here I have this new invoice I'm creating. I have a couple relationships, the company the invoice is to, the company the invoice is from. This company, of course, has many employees, and each employee has an auth record. And because of this signature, I know who originated this transaction, meaning I have a linkage here already to this auth record. Here is a simple smart function that would enforce this rule. And all it does is say, does this relationship exist? And the relationship is the new invoice, if it follows the from field here, and then it follows the company employees field here, and then it follows the auth field, does the auth ID of whoever sent the transaction doesn't match the invoice, which comes from the link to the proper company. And this one simple rule can secure the entire network about who can submit invoices. And of course, in this case, user Brian, if user Brian is disassociated, or say user Brian is associated to OtherCo over here, no rules had to change in the system. The data changed, and therefore what Brian can do dynamically changed with it. So that's a very simple example of a smart function and a rule that's being enforced in the system. And of course, we have lots of functions and lots of capabilities to maintain this sort of security. So assuming that the data got written, assuming it passed all those transactional checks, what does the data look like? And this is really where RDF comes in. So Fluree, we call a piece of data a flake, but it's really just a simple extension to the RDF format. RDF is also often called triples. And in fact, an RDF database, you'll often hear referred to as a triple store, or an RDF graph database or semantic database. So RDF really defines these three initial key concepts: subject, predicate, object. And Fluree really extends it with a few additional pieces of information that introduce concepts of time travel. Also introduce additional metadata within whatever can be transacted within Fluree. An important thing to know about RDF is it's so simple. Every piece of data that you could imagine can be represented as RDF data, meaning reading RDF data, you can import this information into any existing or historical or future database, or read it and trigger actions based on anything. It's just this very simple but very universal way of representing any piece of information you can imagine. And certainly it sits at the foundation of what Fluree does. So these RDF triplets with our extensions effectively are here. They're organized into blocks, and this creates the append-only log. And then out of that, Fluree dynamically is creating these time-traveling graph databases, which then, of course, you can query via any of those three interfaces we talked about. So that sort of wraps up the end-to-end as far as a simple walkthrough of how a transaction happens, how we turn it into RDF data, get a broadcast out, turn it into a time-traveling graph database, and allow your applications access to it. So that'll conclude what I'm going to go through here today. Just a high-level recap. What are some of the things that you can use Fluree to do? So Fluree is a toolkit that can do an immense amount for you. Certainly one of them is you can use Fluree to create custom enterprise blockchains. You can use Fluree as a tremendous data store for microservice architectures, leveraging things like its time freezing capability. You can allow Fluree to power a consortium blockchain network. Semantic web applications, Web 2.0 style applications can be trivially powered by Fluree. Web 1.0 type applications can be powered by Fluree. Fluree gives the ability to give provability and security to the information. So you can reduce things like auditing costs or just provide more trust to the people who are consuming that information. And it's an ideal format, again, for today's applications and today's needs, how it needs to get information out. So for next steps, if you're interested in learning more about Fluree, you can go to our website, fluree.ee, and you can download Fluree for free or sign up for an on-demand account for free and start playing around. We have a pretty extensive documentation website, including videos, tutorials on how to start using Fluree. We have our next webinar, which I'm excited to do. We will literally build an end-to-end blockchain-backed modern Web3 application in 30 minutes. So that will be everything from defining a simple schema to using, in our case, we'll use a React front end that is updated in real time based on blockchain transactions. And feel free to get in touch with us with any of these emails as well. So I'll jump over. I know we got, looks like a couple questions. If anyone has additional questions, feel free to enter them into the system. And just let me read one here. Yeah, so the first question is around signatures, and I'm assuming transaction signatures. And the question is, are there any plans to add signing libraries for languages other than TypeScript, like Python, C++, or Rust? So one thing that we have done with Fluree and our signatures is we actually support, effectively to the T, Bitcoin signatures. So any library that you could use to basically sign a Bitcoin transaction effectively can be used to sign a Fluree transaction. In fact, you can use the identical private keys. You can have an identity on, say, Bitcoin and the same identity on a Fluree blockchain network. We do have the capability of supporting other, we use ECDSA for our signature technology. We do have the ability to support other curves and some other flexibility in there beyond that, but out of the box, effectively, we are using the identical algorithm that Bitcoin is using to sign algorithms, mostly for this, for the compatibility reasons, and because it's an effective and good approach. We have another question here asking about some of the main differences between, say, Fluree and blockchain DB. I am not aware of blockchain DB per se. There is something with a similar name called Big Chain DB. That may be what you're referring to. And Big Chain DB itself is built on top of a NoSQL database. So certainly one key aspect there is that Fluree is designed from the ground up as a semantic graph database, not a document database. Fluree fully supports ACID compliant transactions. Most, of course, document or NoSQL databases do not. And really the analytical and query capability that Fluree has as a graph database, far exceeds what you would get from a traditional document database. We also introduce things like time travel, and then Fluree Smart Functions allows you to secure the data and embed custom logic directly into the data store itself. So those are just a few of the differences. There's probably more differences than there are similarities between Fluree and, in this case, Big Chain DB. Another question, can you integrate Fluree into any Hyperledger projects? Absolutely. So in fact, we would like to have some out-of-the-box examples, which we don't currently have on our documentation website for how this can be done. But the key advantage for, say, a Hyperledger Fabric combined with Fluree is that Hyperledger and its smart contracts, it's largely based on models that Ethereum put out, which are largely based on these financial-oriented use cases, programmable money, so to speak. And while you can jam data into these things, in the case of Ethereum, it would be immensely expensive. I haven't done the calculation lately, but I did it not that long ago, and a gigabyte of data stored on Ethereum would cost you in the range of $5 million US. Now it's stored forever, but you could go to S3 at Amazon Web Services and pay about 3 cents a month for that same data storage. So to be fair to Ethereum, it was never designed to be a data management platform. It was designed to facilitate financial transactions. And its programming capability is there mostly to facilitate custom logic around financial transactions, programmable money. Therefore, Hyperledger Fabric is much the same way. So when you have financial related use cases, these are excellent technologies to look at because they're very much designed for that. But an enterprise application involves so much more than just financial transactions. And of course, what most people end up doing is they build a traditional application on a traditional app stack, and then they go through great sort of efforts to integrate Hyperledger and try and keep it up to date. But you can't really query Hyperledger or Ethereum directly because the data is not structured. If you're storing data in it, it's in a very proprietary format. It's in your custom code as variables. Fluree focuses on all inputs and outputs being in this RDF industry standard format, which is what ends up facilitating further up the stack our ability to actually query it like a normal database. So Fluree can be an excellent complement to Hyperledger when Hyperledger is being used to facilitate financial transactions across multiple parties. Fluree can really back the rest of the data and the entire application that it's being powered from. And that is our last question. I really appreciate everyone joining. I really encourage you. We do not have the webinar sign up for the next webinar quite yet, but we'll send out an email making sure you have that, and we'll update our website probably tomorrow with an updated link for the next webinar, which will be a live code, 30 minutes. We'll build an application start to finish, a real-time React-based application based on a decentralized blockchain. So it'll be exciting. Look forward to seeing you there. Thanks for your time. Bye.